What do you call security guards working outside of Samsung shops? Guardians of the Galaxy. Hey guys, okay, let's work on number 2 of our balanced versus unbalanced net force worksheet. So my car breaks down and I make 3 students, one of them being you, push it to the nearest mechanic. My car has a mass of 1,577 kilograms. If we want to accelerate at 0.5 meters per second squared, what will your net force need to be? And if we start from rest, how long does it take us to get to the mechanic 500 meters away? So we now have a forces plus kinematics problem. Let's go ahead and make up a classic variable list. It's going to be an S, XI, a VI, a VF, an A, and a T. And then adding in our new variables, an F net, a mass, and you know what? We're saying F net, that's going to be the total force pushing on the car to get it to accelerate that much, but we want to know for each student. So we're going to have a force per student. So let's go ahead and make an FS as well. Okay, so the mass is 1,577 kilograms. We want it to accelerate at 0.5 meters per second squared. The mechanic is 500 meters away. And we're going to assume a starting position of 0. We get to choose that. I'm going to choose 0. That makes it nice and easy. And we're going to assume an initial velocity of 0 as well, because the car is not going to start moving until we apply enough force for it to accelerate. So the initial velocity is 0 meters per second. Okay, so what we're missing here is the time and the F net. So let's start with finding the force. After all, that is the first part of this problem. So to find the force, we use good old Newton's second law. F is equal to ma. So we're going to find our net force first, and then we'll find the force per student. So F equals ma. That's going to be 1,577 times 0.5. That's going to get me an F net of 788.5 newtons. Let's go ahead and put that into our variable list. 788.5 newtons. And then, how are we going to find the force per student? Well, I know that we have 3 students creating a net force. So my equation would simply be 3 force of students equals F net. So then I can just divide both sides by 3. So F net divided by 3 will give me the force of my student pushing, force of you pushing. And that's going to get me 262.83. So F, force of the student, is 262.83 newtons. Fantastic, that's our A part. Now, for the B part, we want to know how long it will take to get to the mechanic. So, for that, we're looking at time. And we find time using our handy-dandy S equation. So, let's take a look at that. S equals xi plus VIT plus 1/2 AT squared. Something we've done 1,000 times before. Our xi is 0, drop it out. Our vi is 0, drop that term out of there. So S is equal to 500 equals 1/2, and I know my acceleration is 0.5 because that's what I calculated to determine my net force, and then T squared. So 1/2 times 0.5 is 0.25. Still T squared equals 500. Then divide both sides by 0.25. And that's going to get me, the 500 divided by 0.25 is 2,000 equals T squared. So we're going to square root both sides, and that one I cannot do in my head. The square root of 2,000 is 44.72 seconds equals t. So, 44.72 seconds. And there we go. We've solved our first problem using both forces and kinematics. Congratulations.